may I present to you the number one flat Earth proof. Here in reality, we live on a flat plane, and this may be news to people. We also have a flat sky plane above us, where the celestial bodies exist. From the vantage point of our flat plane, when viewing the celestial bodies, we perceive their position and movement as a dome. This is purely our perception from this vantage point on our flat plane. It's not actually a dome above the Earth. All celestial bodies rise in the east, move in an apparent semicircular motion above the sky, and set in the west. Now don't get me wrong, our Earth is measurably, observably, and obviously contained. But it just doesn't have to be a dome shape, or any shape for that matter. But I digress. Looking at this flat celestial plane above our heads, we can see that everything rises in the east, moves across the sky, and sets in the west. We just perceive a motion of a dome shape. So let me give you a real-world example of how this works. This is Lake Woolloomboola. Now, relative to the horizon, if you look up, straight up above your head, 90 degrees, to where my drone is sitting, right there, 90 degrees, what will happen when that drone moves straight ahead in its own flat plane? It's not going to change altitude, it's just going to move straight ahead. From my observer point, what's going to happen? The angle is going to change. The drone has not changed altitude at all. It's just changed the distance from where I'm observing it. If it moves again, the angle changes again, down to 25 degrees there. As it continues to move away, or if I move away from it, it'll travel towards the horizon, lowering in its angle, and eventually it'll get so far away that the angle will be too small for me to see, and it will appear as if the drone has set. This is all relative to the observer point. This is all apparent. It's not actually lowering. It's just getting too far away, and the angle is decreasing. This creates that dome motion and movement that we see in the flat plane of the celestial bodies. Now that we understand that the flat celestial plane above us presents itself as a dome to our perspective point down here on the plane that we exist, we can understand how the celestial navigation actually works. Every star in the flat celestial plane has a position relative to our flat plane where it will be 90 degrees. This is called the geographical position, or the GP, of that star relative to our flat plane here on Earth. When the observer is at the GP of the star, it appears 90 degrees above their head. Celestial navigation works by using a sextant to measure the angle of that known star and using its relative GP, geographical position, to know where you are. And I'll continue to point out that measuring angles to celestial bodies only works if we are on a flat plane. Now, if one observer measures 30 degrees to a star, and another observer measures 30 degrees to that same star, we can conclude that they are both on what's called a circle of equal altitude. And this is another killer blow to the globe right here. Everything on that circle of equal altitude is exactly that, equal altitude. No matter where you are on that circle, you're going to measure 30 degrees. And through being able to measure an angle to that star relative to the horizon, everything on that circle, in between that circle, in the area of that circle, is absolutely flat and level. By doing this once with a sextant, you know you are somewhere on that circle of equal altitude. To triangulate your actual position, you need to repeat these steps with other stars Your position is where all these areas of equal altitude meet. This is how celestial navigation works and has always worked on our flat, level plane.